Okay, the last thing that we have to talk about with insects is the fact that the environment can influence how um, quickly or slowly they go through their life cycle. If you remember last class, we talked about the fact that insects are cold-blooded, so they are greatly affected by the environmental temperatures around them. If it's warm, it's going to speed up their development because they'll be warmer. If it's cold, it's going to slow down their development. So in our reference table, we have this table, table I, and in this table, it tells you all about the different temperatures. So room temperature is considered to be 72 degrees. So if we look at the two temperatures here, 55 and 65, those are colder than room temperature. And all of those are going to delay the development of the insect. The warmer temperatures, warmer than 72, 80 and 85, those are going to accelerate the development of those insects. If it's delayed, we'll subtract time, I'm sorry, add time, and if it's accelerated, we will subtract time. So this table, table I, shows the effect of the environment on insect development. So we've included things like temperature, the habitat that they're used to, lighting, and even things like drugs that are present. So if we look at different conditions, the first one we'll look at is the fact that we have a delayed temperature. So colder than normal temperatures are going to slow down their development. So in that case, we are going to add time, right? If I delay you on the highway, maybe there's a traffic accident or something, it's going to add time to the amount of time that it takes you to get there. So if we look at this example, it tells you here that this example is at 65 degrees Fahrenheit, so that's colder than the room temperature of 72 degrees. We have two insects with two different sizes, so the blowfly is 27 and a larva, the skipperfly is 15 millimeters and also a larva. These two, we just went over together how to figure out that table. So I'm not going to go through that again. That's directly from table H. I just look up the size and the stage of development that it's in. The next three columns, these are the ones that are different. So these where you will see if you have a drug or a temperature change. So the first thing we're going to fill out is whether or not it accelerates. So again, we're dealing with cold temperatures, so they are going to delay. So both of them will delay. I like to put in the plus or the minus. You don't necessarily have to do that. It just makes it easier for me to remember. So then I have to look up 65 degrees and the blowfly in table I. So if I look up 65 degrees, which is the shaded row, and the blowfly, which is here, it's going to delay its development 3 days. So into this table, I put plus 3. I now add that plus 3 to both the starting number, so 10 plus 3 is 13, and also to the ending number, which is 11, so 11 plus 3 gives me the 14 days. If I do now the next one, the skipper fly at 65 degrees, and I look in my table, so again, we're still at 65 degrees, but now I am dealing with the skipper fly that's going to be delayed only 1 day, so they're not as greatly affected. Okay, so then I put in 1 day, I add it to the 12 days that it would be under normal conditions, and I get 13. So if you looked, in this case, we had no overlapping days, but when we take into account the temperature, the overlapping time now is the 13 days. All right, so those ones were just delaying the time. Now if we look at the next one, we're going to accelerate the time. So those will speed up development, right? If you hit the accelerator in your car, you're going to go faster. Examples of this for insects would be warm temperatures and also the presence of drugs. And in these cases, we're going to subtract time from the time that it takes under normal development. All right, so if we look at the example on the next page, again, this column, we're just using table H. We've already gone through that together, so I won't go through it again. So now we're dealing with 80 degrees, so that's above, that's a warmer temperature than the room temperature. So these are all going to accelerate. So like we just said, when we accelerate, we subtract time. So I just have to go back to that table. I'm looking at a house fly for 80 degrees. So if I go back to table I, now I'm in 80 degrees and the house fly, it is accelerated by 1 day. So I'm going to subtract 1 day from both of those times. So we're going to go 11 to 16. And then the next one, if I look up the blowfly at 80 degrees, So 80 degrees and the blowfly is going to be accelerated 2 days. So I'm going to subtract 2 days from both. That gives me 10 to 11. So the biggest number from the first column and the smallest number from the second column, those are both 11. So it is going to record and take 11 days since the person died. All right, what I would like you to do is to do the You Try It on the bottom of page 15. There are 2 examples for you to do. Try them both, call us over, we'll check it over, and once we get those done, we'll be ready to start the lab.